Hello dear students, welcome on this video lecture. This is our fourth lecture in unit and dimensions. Prior to this lecture, in the three lectures we have talked about certain things. So let me recap that portion, and you will be able to recall that. We have talked about what the physical quantities are. Then after we talked about what the units are. So we have talked about units. In the previous video we started discussing about dimensions. So we were talking about the dimensions, we talked about what the definition is and then other aspects of it. We were talking about the use of dimensions or dimensional formula. We have talked about the two important uses. One was to convert from one unit to another unit. So conversion of unit. So if we want to convert from one unit system to another, we can use the dimensional analysis or dimension. And the second that we talked about, to verify a given physical equation. So that means it is used to check dimensional correctness of a given physical relation. Dimensional correctness. So we can check the dimensional correctness of an equation that is given to us or a relation that is given to us. The important point that we talked about, a physical equation has to be dimensionally balanced. And if we are getting any relation to be dimensionally balanced, we cannot claim otherwise that that's going to be a physical relation or equation, right? So this is a necessary condition for any physical relation, but that's not sufficient. That's what it says. Now in that sequence, the third we are going to learn in this video. We will start from this third, and the third is going to be to derive a relationship or to make a relationship or to form a relationship. So to form a formula if we know what the given physical quantities are and how that relates with that. So let's go for this and we will learn this in detail. And this is an important application of dimensional analysis. So we are going to carry with this dimensional analysis, and in this dimensional analysis the third aspect of use of units and dimensions is to form a relationship or formula. So to form or establish a formula between physical quantities. So that's the next application and important one. What this says, this simply says that if we know that a particular physical quantity depends on other physical quantities, and we know by what factor that depends, then we can form a formula. Right? And the better would be to see some examples how that formula can be formed. So let's take an example and we try to learn how that formula we can derive or form using this dimensional analysis. So in this basic example, let me write the example over here. It says time period of simple pendulum you might be knowing what a simple pendulum is. So time period of a simple pendulum, that is t for time period, that depends on length of the simple pendulum L and gravity of that space, which is g. So this is given to us. The time period of simple pendulum depends on the length. L is representing the length of the wire, and the gravity at that location where the simple pendulum is. So it depends on these two physical quantities, and this is demanding to form. That means it says find expression of t using dimensional analysis. So it is asking for expression of t based on these parameter dependency and using the dimensional analysis method. So how we proceed, I'm going to illustrate over here. You need to watch it. So this is the physical time, is the physical quantity that we need to find. So we'll write that this time is going to be dependent on, proportional to, and this will depend on L. So it will depend on L raised to power, let's say A, and it's also depends on G, so G raised to power B. So these A and B are unknown that we are going to find. So this is how the time period depends on the length and the gravity. We can remove the constant of proportionality and we will bring a constant of proportionality k. The symbol of proportionality I have removed and k is a constant over here. That's a dimensionless constant. And L raised to power A and G raised to power B. So that becomes the expression or relation. Now we need to find out what the A and B are. To find A and B, what we need to claim that this has to be dimensionally correct as well. So to make the dimensionally correct, we will try to write the dimensions of left hand side and dimensions of right hand side. So now we will be writing the dimensional formula on both the sides. Now this is T for time period. Time period will have a dimension of T. So left hand side will have a dimensional formula, simply T. Or if we write properly, we can write it as m raised to power 0, L raised to power 0, T raised to power 1. Now let's write on the right hand side. Right hand side k is a dimensionless, so it will have a no dimension. That means m raised to power 0, L raised to power 0, T raised to power 0. This is L. So length will have a dimension length L. So it will be going the power A. And if we go with this G is acceleration, so it's going to be L T raised to power minus 2 and thus power B. If we simplify this right hand side further, so we will find m raised to power 0, no m is coming, and L raised to power in totality will be, so we can this handle the powers. This is L raised to power A, this is L raised to power B. When they are multiplying, the power will be adding up, so A plus B. And then this T has total power as minus 2B. Right, so this is simple calculation we are doing over here. Now we will say if it has to be true, that means dimensions has to be true both on left hand side and right hand side. So the powers of corresponding fundamental physical quantities must also be equal. So if we equate these powers, so we will claim for m power 0 equal to 0, that will give no relevant equation. That means this is trivial relation, that's true always. Now if you go for this L raised to power 0, here L raised to power A plus B, so we can claim A plus B is equal to 0. So that's going to be one relation. Another, by comparing the time dimensions or time T raised to power, so here the T raised to power is 1, and on the right hand side T raised to power is minus 2B, so we are claiming minus 2B is equal to 1. Now if you solve these two relations between A and B, this will say A is equal to minus B, and from here B is coming as minus 1 by 2. So minus 1 by 2 is the value of B, and if we place on the first, we will get plus 1 by 2 as the value of A. Hence we can write this T is going to be equal to some constant and L raised to power A, which is 1 by 2, L raised to power 1 by 2, and G raised to power minus 1 by 2. We know 1 by 2 is square root, so this can be written as T is equal to K square root T square root, and then there is a L, so it's going to be L divided by G. G is going to come downside. Now that this will leads us to a formula, and that formula is of time period that depends on length and gravity, right? So T is equal to constant under root L by G. That's going to be the formula. Now here this K is a dimensionless constant, and we cannot find the value of K using this method. That means this is one of the drawback of dimensional analysis, that we cannot find the dimensionless constant involved in an equation. But yes, we can find out the relation between the physical quantities that are involved there. Now we know this is the formula that we have used n times, or you might be knowing. So if we try to find the value of k by other method, you will find that k will come out as a 2 pi. So the exact formula is t is equal to 2 pi under root L by G. Now here 2 pi is a dimensionless constant that can be found out by using other concepts of physics. But by using the dimensional analysis, we can establish the relationship between these quantities. That means t is directly proportional to under root L and t is inversely proportional to under root G. So this is an example that illustrates how to form formula or relationship among the physical quantities. We will take another example to use the same thing and make you more confident in grasping it. So here is the example, another example. That example reads as force F depends on radius, velocity and viscosity coefficient eta of a medium, and this radius and velocity they are of a spherical object. So there is a spherical object which is moving with velocity v and having a radius r, and that is moving in a medium having viscosity coefficient eta. So the detail of this question will be learned later on. But yes, in short, the force, the quantity that is force that is dependent on radius of the spherical object which is moving with velocity v in a medium having viscosity eta. And this is expecting from us to find the formula of force using the dimensional analysis. So we can use the dimensional analysis to find the formula of force which depends on these physical quantities. Now you can pause the video and you can try to solve this by using the dimensional analysis, and then you check with the solution that I am providing and verify whether you are getting the same answer. Now if I solve, so how the solution will be, we will be following the similar steps that we learned in the previous example. Dimensional analysis, we will say this force has to dependent on radius, so let's say radius raised to power a, velocity raised to power b, viscosity coefficient eta raised to power c. Then we will claim that some constant has to come in to replace this symbol of proportionality. So F is going to be some dimensionless constant k, and r raised to power a, v raised to power b, and eta raised to power c. Then we will claim that dimensional formula both sides must be identical, that means it must be dimensionally balanced. So on the left hand side, if we write the dimension, so we need to write the dimension of F force, and by using the previous table or the tables given in your books, we can remember what the force is, or we can find out the dimension of force. If you find it out, you are going to get m L t raised to power minus 2. So that is the dimension of force, and which is the left hand side dimension. This has to be equal to k is a dimensionless, so it will have a no dimension. R is basically length, so it's going to be length raised to power a. Then we will need to write the dimension of v. V is the speed of velocity. Velocity is length dependent and time dependent, so it's going to be length t raised to power minus 1, thus power b. And now viscosity coefficient, we need to remember what the dimension of viscosity coefficient is. If you look at table, then you will find it is m L raised to power minus 1, t raised to power minus 1, and this entire power is c. So now we will be simplifying this right hand side and will be comparing with this left hand side. So let's simplify this right hand side dimensions. M, we will get the m raised to power c, then L raised to power a from here, b from here, and minus c from there, so it's going to be a plus b minus c, and total power of or total dimension of t on the right hand side is going to be minus b, and from here you'll get minus c. Now if we write this left hand side, in left hand side we are having m raised to power 1, l raised to power 1, t raised to power minus 2. Now if we compare these dimensions on both the side, so on comparing the dimensions on both the side, we will find few equations like c is equal to 1. So we got the value of c, and comparing the L dimensions, so we will get a plus b minus c is equal to 1. So that's another relation, and the third relation will be by comparing the power or dimensions of t. So that says minus b minus c is equal to minus 2. We can easily solve these three equations. We got c equal to 1, we can place on this third one. So from here we can find out what the b is going to be equal to. So if c is replaced as a 1, so this becomes minus 1, it goes there, so it becomes again minus 1, so b comes out to be 1. So from here we are getting b as 1. Now putting the value of b and c on this, we can also find out what the a is going to be. So comparing this, a is coming as 1. So ultimately we are getting a as 1, b as 1, c as 1. Since we are getting a, b, c as 1, 1, 1, then the formula from these calculation or analysis, from this analysis is going to be f is equal to constant and r raised to power 1, v raised to power 1 and eta raised to power 1, which we can write it as f is equal to some constant into eta r v. So this is what the formula ultimately becomes. So that's the relation between the quantities that we have listed in the question with the quantity that we were demanding, that's a force. So force depends directly on radius, force depends directly on velocity, force depends directly on viscosity coefficient. Again, this is the limitation that we cannot find the dimensionless quantity k. Now later on you will learning that this k can be found using the some experimental methods. So if we are able to find k, then we will be able to get the ultimate or final relation. If you if you read further, then you will find that this k for this particular case comes out to be 6 pi. Hence the final formula that is there is f is equal to 6 pi eta r v, and that's formula that talks about how viscous force acts on a spherical object of radius r moving with velocity v in a medium of viscosity eta. Right, so that's an important formula, and this is the derivation of this formula, and the derivation or the formula that we have established by using the dimensional analysis. So this is the method we are following. That's a straightforward method. In each and every relationship where we need to find a relationship, we need to write that relationship starting like powers and then writing the dimension both sides, simplifying these equations and come to this thing, right? If you're comfortable with this approach that we have discussed over here, then that's sufficient. Now based on this approach, let's do a question or a couple of more questions which have come into the examination, JEE Main and Advanced. So let's see the next question based on the same method. Here is the question. Question reads, a liquid drop of density rho, radius r and surface tension sigma oscillates with time period t. So there are a lot more information that there is a liquid drop and surface tension and the oscillation, then finding the time period. So this is all aspect of physics we will be dealing in the respective chapter. But yes, if we know that this time period depends on surface tension rho, radius r and density rho. This surface tension is sigma. This is read as a sigma. So this is read as a sigma. And this is read as a rho. So rho and sigma. Anyway, so this is a relationship that it talks about. Now further it reads, which of the following expressions for t square is correct? So we need to find this t square will depend on these quantities in what manner. There are four options, A, B, C and D. We need to find which option is correct. So what you can do, you can pause the video and solve this question and identify the right option, and then see what the solution that I am providing, are you doing in the similar manner or you are getting the same answer, right? So now let me solve it for you. So solution, we will proceeding in the same manner. We need to find out t square, so we will say, let's say this t square depends on these quantities like density raised to power a, radius r raised to power b, and surface tensions sigma raised to power c. Now once we are able to find a, b, c, then our answer will be clear, right? Then we will say, let's remove this proportionality symbol and write it as a t square is equal to some dimensionless constant and rho raised to power a, radius raised to power b, sigma raised to power c. What we need to remember, or we need to find out the dimensions of each and every physical quantity that are involved over here. So now we will be writing the dimensions on left hand side and right hand side, then we will be comparing. So writing the dimensions on both the side. This is time period, that's a t. So t will have a dimension t, so we will write a t raised to power 2 versus square of t, so we are writing t raised to power 2. On the right hand side, this k is a dimensionless, so we will have say this dimensions are need not to be written. Rho is a density, and we know what the dimensions of density is. Density is mass per unit volume. So mass is m, volume in division is t raised to power minus 3. So that's going to be power a. So that's a density. Then we will write radius. Radius is a length, so we will writing length L raised to power b. Then there is a surface tension. Surface tension we have talked about in the list, or you can see the list for the time being, and it's written as a force per unit length. So that will be converted into m, and t raised to power, L raised to power becomes 0, so I'm not writing that, t raised to power minus 2. And this entire power will be c. So this is how I have written the dimensions on left hand side and right hand side. Now let's carry on and simplify these right hand side dimensions. So we are going to get m raised to power in totality as a from here and c from there, so a plus c. When we go for L raised to power, we are going to get minus 3a from the first plus b from the second. How am I able to write these things? I hope you are able to understand. This was L raised to power minus 3. When the power a comes in, so they get multiplied, so this becomes minus 3a. And L raised to power b over here, when they gets multiplied, so the powers gets added up, so this becomes this. And then finally t, so t raised to power, you will find t raised to power minus 2c. Now this is right hand side as per the dimensions, and if we write properly left hand side, so we will find m raised to power 0, L raised to power 0, t raised to power 2. Now we can compare these dimensions on both the side and can claim these dimensions has to be identical. So by comparing the dimensions on both the side, we will finding some equations like a plus c is equal to 0. And from the second, we will be finding minus thrice a plus b equal to 0. And the third equation or relation we are going to get as a minus 2c is equal to 2. Now we can handle these equations to find out a, b and c. If we see the last equation, we can find c directly. C is coming as a minus 1. Then we can put the value of c in the first to get the value of a. So a has to be plus 1. And once we know a and b, then we can find out the value of once we know a and c, we can find out the value of b by using the relation second, which is this one. So b is going to be equal to thrice a is this, so b is going to be 3. Once we know a, b and c, then we can come back to write the final expression of t square. So this t square is going to be equal to k, which is the dimensionless constant, rho, which is the density raised to power 1, then r, which is radius raised to power b, which is 3, and sigma raised to power c, which is minus 1. So we will say from here that t square is equal to k, and it becomes r cube into density rho upon surface tension sigma. So this is how the relation between the given or among the given quantities is. So t square depends on this rho r cube upon sigma, or you can say directly proportional to this factor. Then we will see the options. There are 4 options. So A option is going to match correctly, rho r cube upon sigma. B definitely is not matching, C is not matching, so not D. Single correct, A option becomes correct. So we can claim from here the answer becomes option A. Now this is a proper illustration how we proceed. We take this quantity, we make the relation, then we put the parts, then we simplify. That means we write the dimension both sides, make equations, simplify. That's a straightforward fixed standard rule, you can call it. And there are questions coming on it. This is also a question that has come in entrance examination, right? So we can solve this in this way, and we can find our answer. Mind it, learning proper is very important, and if this type of question is coming in the examination, it's important to get the correct answer in one go. Now let's take another example that has come in the examination advance, and try to find that answer using the same methodology that's called dimensional analysis. Here is the question. You can read the question and try to solve it after pausing this. And we need to find the value of n. So try to find the value of n and then match it with the solution and answer that I'm going to provide over here. So let me read it to solve for you. And it says, to find the distance d over which a signal can be seen clearly in foggy conditions, a railway's engineer uses dimensional analysis and assumes that the distance depends on the mass density. So the quantities that are going to come here is, one is the mass density of fog, intensity, which is power per area, S of the light from the signal, and the frequency f. The engineer finds that d is proportional to s raised to power 1 by n. Then find n. So there is a description of the question and related to the engineering background. So for us, the focus will be on the quantities that we are interested in. So the targeted or to find quantity is a distance. So distance d, it depends on certain other quantities, which is the mass density rho, and intensity is power per unit area, and also it depends on the frequency. And we need to solve this by using the dimensional analysis method. So we will be proceeding in the very similar fashion as we had solved the previous couple of questions. So let's try to solve in a very similar manner and try to find out this answer for this question. This was a subjective question and was asked as a value, numerical value. So we will say this distance has to dependent on these quantities like density raised to power a, and then intensity raised to power b, and then frequency raised to power c. And then we can claim there is some dimensionless constant, let's say that is k, and that's the rho raised to power a, intensity raised to power b, frequency raised to power c. In the next line we are going to write the dimensional formula for both the side. We will be writing the dimensional formula for left hand side. It's a distance, that's a simply length, so it becomes L is equal to, on the right hand side k is a dimensionless quantity or number, so we can say it's not going to make any difference. Rho is a density, that's a mass density, that means mass per unit volume, and we know what the dimensions for density is, it's m, that's a mass per unit volume, that means L raised to power minus 3, entire power is a, and then there is a S for intensity. Intensity is power per unit area. So we can separately do calculation to find out what this unit intensity will be if we don't know. If we remember, that's good. Or what will be the case once you have learned the entire physics, then you will be knowing the relationship for intensity and then power and everything else. As of now, you might be remembering or need to search for the formula. So if this is intensity, intensity is said to be power divided by area. Now we know power is basically energy per unit time. So area into time. Now if we write the dimension of this intensity, then we need to write the dimension of energy. And if you write the energy dimension, you will find ml2 t raised to power minus 2, because the force into length. And then you can say you need to write the dimension of area, which is L square, and dimension of time, which is T. So if you assemble them properly, then you will get the final dimension of intensity. It's going to be M. This is L square, this is L square. When it goes upside, it gets cancelled out, right? So that's get cancelled out, and T raised to power minus 3. So that becomes the dimensional formula for intensity. Now let me place the value of intensity dimensional formula, which is M T raised to power minus 3, and this will be powered by B. Frequency is 1 upon time period, so it's going to be T raised to power minus 1 power C. Now let me assemble right hand side and write this left hand side properly. So it's going to be M raised to power 0, L raised to power 1, T raised to power 0. And then on right hand side, after assembling, we will find the M raised to power in totality will come as A from here and B from there, so A plus B. Similarly, we will try to write the total power or dimension of L. So it will come as a minus 3A from the first, and that's all. And let's come to this T. For T, we will finding it as a T raised to power minus 3B from the second term, and minus C from the third term. So I've separated them, or you can write in a single bracket, it's okay. Now what we need to do, we need to compare these powers or dimensions. So dimensions of M for both sides has to be equal. That means M raised to power 0 must be this. So from here we will find A plus B equal to 0. So that's one relation. Now power of or dimensions of length, which is minus 3A, and this side it is 1. And for time it's a minus 3B minus C, which is equal to 0. Now we can solve these three equations and we can find out the values. A raised to power we are going to get as minus 1 by 3. So A value is going to be equal to minus 1 by 3. Using the first, we can find out the value of B. B is going to be equal to minus A, which is going to be 1 by 3. And we can also find the value of C by using this. So C will be equal to minus 3B. So the C value will come out as a minus 3B. So that becomes minus 1. Anyway, what the demand of the question is to find the power of S. So if I had to write the formula, I can write the formula. The formula comes out to be D is equal to K density raised to power 1 by 3 with a minus sign, intensity raised to power 1 by 3 with a plus sign, and F raised to power minus 1. Now our interest was to power of S. So what is the power of S? Is 1 by 3. And if we compare with this, so from here we can say, after comparing, the 1 by 3 is equal to 1 by n. So what the n value is going to be equal to? We will say n value is going to be equal to 3. That will become our answer. So this was integer question, in which that means answer was coming as integer and the integral answer is 3. Right. So this dimensional analysis we have used over here. Whatever was given to us, we found a relation and then used the dimensional formula both sides, then simplified and found our answer. So if we have understood this method, we have prepared for one type of questions in the examination. This is a question that have come into JEE Advanced in numerical type. So this dimensional analysis is important because it is being asked in the examination as a question, even in the advanced paper, right? So idea is simple and it has to be digested. So this is another example. Let's take one more example in which we can change the quantities, or we can call another quantities as the fundamental quantities. So that will be also beneficial. So let's go for the next question. So next question is here. Let me read what it says. Question says if the velocity, acceleration and force are taken as fundamental quantities instead of mass, length and time, then what will be the dimensional formula of Young's modulus? So we need to find the dimensional formula of Young's modulus, but we are shifting from the fundamental quantities mass, length and time that we used to take as a fundamental. New fundamental quantities that we need to consider is the velocity, acceleration and force. As we discussed in the beginning, when we talked about the physical quantities are fundamental derived, that means whatever the fundamental quantities that we have taken, these are something that we have identified these quantities as a fundamental quantities. Now, so we can always have another set of quantities as a fundamental quantities, and we can talk about all other quantities in terms of those fundamental quantities. So this is again a question which has come into the examination. So we need to see how we will be solving this question, and whenever the fundamental quantities are assumed to be something different or some different set of quantities, right? So let's see how we can solve it. Now again, you can pause it and try by yourself and try to find out your answer. There are 4 options, A, B, C and D. You will find your option out of it. So let me solve for you over here. How we are going to proceed, idea will be very similar. We will say that we are trying to find out Young's modulus. So this Young's modulus Y is going to be proportional to velocity raised to power A, area raised to power B, force raised to power C. So whatever the fundamental quantities we are opting, we will choose those quantities and give these powers. Again, this proportionality constant has to be introduced and this symbol has to be removed. So Young's modulus is going to be some dimensionless quantity, velocity raised to power A, area, this A for acceleration, A for acceleration power B, and F of force raised to power C. Fine. Now, since this is a formula and this, if it is true, then it must be dimensionally true. So we are going to write the dimensional formula on both the sides. And what our purpose is to find out A, B and C. So if somehow we can find A, B and C, then our answer will be done. So we are going to write the dimensional formula on both the sides based on the dimensional formula that we know in terms of M, L and T. Now this is a Young's modulus. Well, you might not be aware what the Young's modulus is. So we can borrow the table, and from the table we can write what the Young's modulus is. So you'll find the Young's modulus will have a dimension or unit very similar or same as the pressure. So if we know that, from there we can derive the dimension of this Young's modulus. So is going to be some sort of this Young's modulus dimension is same as dimension of pressure. Dimension of pressure, we know that's a force per unit area. So we can say force is M L T raised to power minus 2. That's the force. That's how we write the force. And area is L square. So if we simplify this, this will convert into M, the dimensional relation, L raised to power minus 1, T raised to power minus 2. Over the time, once you have studied about these formulas, you are not supposed to remember the dimensional formula. You just need to remember the formula. You can quickly come to the dimensional formula. So let's come over here and write the dimensional formula of Young's modulus, which is M L raised to power minus 1 T raised to power minus 2 is equal to, again K is a dimensionless, V is a velocity. We know velocity is length and time inverse, so power A. Then this A is for acceleration, that's going to be length time raised to power minus 2, that's a B. And then the force, we have used the force over here, and force dimensional formula is m l t raised to power minus 2. You will be using these quantities like force and number of times, so you will be this will automatically will make a print in your brain, and you can remember this over the time. Now let's simplify this right hand side and collect all the quantities or dimensions. M raised to power we will get as a c. L raised to power in totality will be coming as a from over here and b from there, so a plus b, and c from there, so a plus b plus c. And for t there is going to be minus a, then minus 2b, then minus 2c. So this is this. Now on the left hand side we had already this m, which is raised to power 1, l raised to power minus 1, t raised to power minus 2. Now we have written the dimensions both the side. Now we can compare the dimensions and make the equations, simplify those equations to get our answer. Now if we compare, we will find c is equal to 1 by comparison of dimensions of mass, then a plus b plus c for length dimension will be minus 1, then minus a minus 2b minus 2c. If we use this or we compare the time, this is going to be minus 2. Now we can find out the values of a, b, c. C is already known to us. If we put the c value over here, so this will become a plus b is equal to, in place of c I am writing 1, so 1, and this goes to the another side making it minus 1, so minus 1 minus 1 minus 2. Similarly, from using this we can say we will be finding it as a plus 2b. Now these are the two equations we can solve anyway. So c is 1, so if we place c as 1, so it's become minus 2 and 2 minus 2 get cancelled out, so that means this becomes equal to 0. Now from here, can you find what the a and b are going to be equal to? Just to find that thing, you can write a over here plus b over here and minus 2. This is how you solve the equations. And you can say we are subtracting, in the minus, this becomes plus. A will get cancelled out if you see properly, and this will be added up to 3b, and this is going to be equal to 2. So we are going to get it as b equal to 2 by 3. Well, some calculation error has come in, so let me recheck. This is this proper, this is this proper. So here we are subtracting it, right? So this is by mistake, so let me complete that. Now we are subtracting these two equations. We are handling, you can handle in any way. This a will get cancelled out. This was 2b and this was minus b, so that becomes b. So b is equal to 2. Good. So from here we are getting b is equal to 2. So once we have got b and there was a c, we can put the value of b over here to get the value of a. So using this we can also find out the value of a by putting this value of b in either of the equations. Let b place over here, so this plus 2, that side is going to be minus 4, so this comes out to be minus 4. So ultimately what we have calculated or found out is the value of a, value of b, value of c. Now these are the three equations. Once we made the equations properly, we can always find the a, b, c correctly. Doing calculation corrects are important. Anyway, let's come back to this. So what the y will be equal to, y is the Young's modulus. So this Young's modulus is going to be some k value, then v raised to power a, which is minus 4, then a raised to power b, which is 2, and f raised to power c, which is 1. If we rewrite it to get the final expression, then we can check which option is the right option. So y is equal to some dimensionless quantity, and we will get as f a for acceleration square divided by velocity raised to power 4. So v raised to power 4. Now this is what the expression we have got. Now we need to see, is there any expression or option that matches with this? So if we go for the option A, it's f a square v raised to power minus 4. Yes, so if it goes upside, so that becomes v raised to power minus 4. That's written over here, right? So which option is correct? The first option is correct. No, if first is correct, so second is not going to match because that's a different unit, this has a different unit, this has a different unit, right? So that becomes our answer. Well, so again, let me summarize what we are doing. We are making the relationship, then we are writing the dimensional formula both sides, then we are solving these equations, then finding the final answer. So that's how we can get the final answer. As I told you, this is also a question that we got that has come in the examination. So this dimensional analysis is quite important and you should focus on it. I hope you have got the concepts that we have talked about in this video. Dimensional analysis, particularly how to get the equation or formula formed based on the dimensional analysis. So this is all for this video, and in the next video we will be talking about some other questions or examples and some other properties of dimensional and units, right? So that will be the final video to cover this unit and dimension chapter. Well, so keep on following. Thank you for watching. Have a great time.